So today we're going to do the last section of the chapter 3, which is about complex numbers, right? So we're going to define what is a complex number, and then we're going to do how to add them up, how to multiply them, how to divide them eventually, right? And before we move on to the next chapter. So, all right. So let me share my screen. Okay, share my document. All right. Okay, so this is like 3.8 complex numbers. 3.8 is a complex numbers. Okay, so far, if we just limit ourselves to the real numbers, there's some stuff we cannot do, right? For instance, if you take the square root of a negative number, if you put square root in your calculator and you put a negative number, for instance, say square of negative 16, your calculator will tell you that is not possible, right? For the simple fact, you cannot square a number and get a negative number, right? That for the simple fact, because if you just consider the real numbers, when you do any number A, when you square A, it's not possible to get a negative 16. That is not possible, right? If you're talking about real numbers. For real numbers, that is not possible. But imagine that we need that. Imagine we need to proceed. If I have a square that is negative, we need to proceed. Imagine I'm an engineer. I want to do some calculations to build my bridge, right? Or to do whatever, to do my electricity stuff, etc., etc. I'm in my research lab. And then I got a variable, and that variable, when I square that variable, is giving me a negative number. And I need to proceed. I need to go ahead and solve my equation. For that, we need a new set of numbers, okay? Actually, the numbers in math, we improve them, according to the need. When we need something, when people need something, they invent new numbers, okay? So you can picture that. You can have the picture of the very first numbers that are known as the counting numbers 0, 1, 2, 3, 4, 5, etc. And then people realize it's not enough, It's not enough just to work with 0, 1, 2, 3, 4, 5, and then they invented negative numbers, okay? And then they say this is not enough, and then they invented rational numbers. Not enough, they invented real numbers, right? So now that is not enough, so we invent complex numbers, okay? This is how we understand it. So, and everything is based on that number right here that I'm about to write right now. It's called the imaginary number, I. The imaginary number, I. Worldwide, everywhere you go, that number is called I, okay? I guess there is a link between the I and the imaginary, I guess. I don't have like the historical fact of that, but I guess there is a link. The imaginary number I is defined by, is such that, and now we have two properties of I. So the first one is I squared is -1. You see? So what was not possible 30 seconds ago, what was not possible now is possible. 30 seconds ago, I was saying you cannot square a number and get a negative number, right? I was saying that 30 seconds ago. Now it's possible now. Now that number I, when you square it, you get -1, okay? So if somebody asks you, what is I? You tell them, I is that number you square and get -1, okay? So now, can somebody tell me what's gonna be the radical form of this one? You see, if I write on the side, if I write 3 squared is 9, what is the radical form of that? We say radical square root of equal what? Can you tell me?
3.
Square root of what?
3.
Square root of, so what I put under, what number I put under the square root? The 9 or the 3?
The 9, sorry.
Square root of 9 equal to what?
3.
3. That is the radical form, right? So can you do the same here and give me the radical form here?
So it would be the square root of I.
Oh, it's the other way around. Of
Oh, the square root of -1, sorry.
is equal to?
Is equal to I.
I. Thank you. So we can come up with a new definition of I. I is like the square root of -1. You see, just like 3 is the square root of 9, 5 is the square root of 25, 7 is the square root of 49, etc., etc. I is the square root of -1. Okay? I is the square root of -1. Everybody agree with that? Okay. So now, because now we know I square root of -1, now we're gonna come back and you see what my calculator was telling me does not exist, which is square root of -16. Now I'm gonna use the new definition to calculate that. So we're gonna do the square root of a negative number. Right? So we're going to do square root of a negative number. So now when I say square root of -16 now, I'm going to view -16 as two things. I'm going to view the -1, I'm going to view the 16, right? Okay? Because -16 is -1 times 16, right?
So is it 4i?
Thank you, 4i. Very good. Because the 16 will give me 4, and the -1 will give me I. So it'll be 4i. So from today, every time you see a negative number inside the square root, you have to know it's going to generate an I. Okay? Every time you see a negative number inside the square root, it hides an I. Okay? The square root of -16 is 4i. So 4i or I4 is the same thing, right? You know, the only thing, you know, when you say 4i, it sounds like math, right? It sounds like algebra stuff. When you say I4, it sounds like, you know, some, I don't know, some IRS form or something like that, okay? But it is the same thing. 4i, I4 is the same thing, right? But we usually write 4i, okay? 4i. So now, what is the square root from that? So let's size the square. What's the square root of -4 then? You're going to say what?
2i.
2i, thank you. Square root of -9, you're going to say what? You're going to say?
3i.
3i, exactly. Square root of -100. So you're going to say this is?
10i.
10i, thanks. Okay, now comes this. How are you going to write square root of -5? What's you going to say? Square root of -5.
Is it just I square root of 5?
Thank you. Because if you don't know the square root, we just leave it as is, right? If I don't know what is the value of the square root, square root of 5 is not an exact number. It has a value, but I don't know that value, right? So I'm going to leave it as is. It's going to be I square root of 5, right? Again, why we prefer this way rather than this way? It is a preference thing. Why do you prefer to put the I in front rather after? Why? Somebody, no, do not. The reason is very simple. Can somebody tell me the reason?
It just like separates them better.
Exactly. Thank you very much. That's the only reason. That's the only reason is to avoid confusion. I explain myself. Every time you put the square root up front, there is a room for confusion if you do this. You see? Do you really know if I is inside or outside? You see, that is matter of confusion. So avoid that. Every time you multiply the squares by a number, you put the number up front, right? That is just to avoid confusion. That's it. There is no other mathematical reason for that. So when you say square root of negative 13, we say this is I square root of 13, right? Okay. So if I ask you to simplify square root of negative 24, how are you going to simplify this?
I square root of 24.
I square root of 24, right? Now, can we do something to simplify square root of 24?
Oh, okay. Do you want us to do that?
Yes.
Okay. 2I
Uh-huh.
square root of 6.
Thank you. That's very good because 24 is viewed as 4 and 6, right? Okay, by the way, don't forget this technique. It's going to be on the test next week, right? See, this technique right here is going to be on the test, right? So, and then the negative one gives me I. So 4 will give me 2. And the square root of 6, I leave it as is. But this is not very nice. You see, this is not very aesthetic. So what is more aesthetic is to put the 2 here and then the I and then this, right? Okay. But the first writing is good. I2 square root of 6 is good. Mathematically, you have nothing against that. But it's nicer and easier and less confusing to put 2I root of 6. Okay. So that is now, from now, we know what is the square root of a negative number from now. Okay. We know what is the square root of negative numbers. From after that, we're going to define what is a complex number. You see, we don't know yet in general what is a complex number, so we're going to define that. You have to bear with me. What is the definition of a complex number? Okay, so definition of a complex number. Okay, so a complex number is any number of the form, any number of the form all right, so you can mute yourself every time you are doing something that is not in the class, for the class. All right. So just any number of the form a plus bi, a plus bi. Any number of this form is called a complex number, where a and b are real numbers, where a, b, real numbers. Remark, I haven't put any restrictions on a, b. I haven't said they must be positive. I haven't said they must be negative. I haven't said they must be different from 0. None of that. A, b are just real numbers, okay? That is a complex number. So this is, for instance, what you call this? We call this algebraic form of a complex number. Why I have to tell you the form? Because if you keep going with math, you're going to see some other forms. You're going to see, you're going to see some trigonometric form, polar form, etc., etc. You're going to see those forms. But for OAG3, we just going to keep that form right here. Okay. So any number of this form is called a complex number. For instance, so is 3 plus 5i a complex number? Is this complex number? Does this match the form?
Sure.
Yes.
Sure, right? It is a complex number. Who plays A?
3.
Who plays B?
5.
5, right? So can we write this one any simpler than 3 plus 5i? Can we simplify it, do you think?
No.
No, thank you. The PM does not allow you to simplify anything here. So the algebra stuff, the algebra rule doesn't allow you because 3 and 5i are not like terms, so you cannot put them together. So 3 plus 5i is exactly the final form. We could have written 5i plus 3, right? Which is the same thing because addition is commutative. But we always, for some reason, we always prefer to write, 3 plus 5i instead of 5i plus 3. But there is no math reason, okay, for that. So for some vocabulary, we say A is a real part of the complex number. We say B is an imaginary part of the complex number. Just in case you see it somewhere, right? Okay, so this is a complex number. When you say negative 10 minus 5i, is that a complex number? Does it look
Yes,
like a
that's
complex
also a
number?
complex number because negative 10 is real and negative 5 is real, but I is imaginary.
Yes, so this is a complex number because it does match a plus bi. Who plays a here?
10.
Who plays
Negative
a?
10.
Negative 10. Who plays b?
5.
Negative 5.
Negative 5. Thank you. So now, is 7i a complex number?
No.
I imagine you say no because you don't see the a, right?
Right.
Can we add a number that's going to make it a? Can we add something up front and it doesn't change anything?
0.
0 plus 7i, right? Since this is exactly the same as 0 plus 7i, so we're going to say this is also a complex number, right? Negative 3i is also a complex number, right? I, 1i, 2i, 3i's, they are all complex numbers. How we call them? We call them pure imaginary. Pure imaginary numbers because they don't have the a. The a is not there, right? Okay, that's for vocabulary. Okay, now look, is 8 a complex number?
No?
Okay, again, let me guess why you said no. You said no because you don't see I, right?
Yeah.
Okay, can you add something that allow you to see I without changing anything?
Make it a negative? Oh, I don't know.
Think about 0. Can we add 0 something?
0i?
Exactly. When we add 0i, it's like adding nothing, right? Because 0i is still 0, you see? Which means that is a complex number. So basically, the bottom line is any number in the face of the earth right now is a complex number, okay? The complex numbers are all the numbers that you know now. They're all complex numbers. So in math, every time we invent a new set of numbers, very likely is going to contain the other set. So, the previous one. If you invent the complex numbers, very likely it's going to contain the real numbers, right? It is a bigger set. So any number right now that we know is a complex number. This is how we understand it. Any number is a complex number, all right? Whether we see I or we don't see I. So now that we have a new set of numbers, we're going to learn how to add them up, how to multiply them, etc., how to divide them. That's just natural. Okay, so look, if somebody asks you to do this, 6 plus 9x, and then plus, you don't need to write it down. You don't need to write this down. I'm just explaining something. Plus 10 plus 4x. Do you tell them you don't know how to do that because you don't know what x is? Or do you know how to do that? Do you know how to do this stuff?
We FOIL.
No, that is, you have a plus in between, okay? We do FOIL if it was a multiplication, but this is an addition, so we don't need to FOIL. So do we know how to do that, or do we know to need what is the nature of X? Do we know to need what X is to do that?
No, we don't need to know what it is to know.
Exactly, right? I don't need to know what X is to know to do that. What algebra tells me to do?
I'm sorry.
Algebra tells me to do the group like
Group like
Like
term.
terms.
like terms. That's it. As long as two terms look exactly alike, we can group them. This is what algebra tells me. I don't need to know what they represent, right? I don't need to know. So everybody's going to say, this is 16, right? Everybody's going to say this is 16 plus what?
13x.
Plus 13x. You see, when you do 9x plus 4x, you don't need to know exactly what x is. You even don't care what x is. You know, because they are exactly like terms, it's going to be 13x. Now remove x and put I. You see? Now remove x and put I. Are we able to do it?
Yes.
Yes, right? Do we really need to know what I is in this case here?
No.
We don't need to know what I is. We know I is a complex number. I is a pure imaginary number, but we don't need it here for this case. If you want to add complex numbers, you don't need to know what I is. The definition of I does not play any role right here. This is 16 plus 13I, right? The definition of I does not play no role whatsoever when you add complex numbers or when you subtract them, right? For instance, when you say 9I minus 6I, I don't need to know what I is. How much is this? It's just
3i.
3I. I don't know exactly. I don't need to know what I is. Okay, that is how simple the addition is. Adding, subtracting complex numbers. Add, subtract, multiply complex numbers. So go ahead. Can you do this two addition at least? You know, can you do like, 20 plus 17I plus 9 minus 8I equal, and then negative 3 plus 4I minus 1 minus 2I. Okay, go ahead. Do this addition, do the subtraction. Again, for the subtraction, you have just be mindful about the negative sign in between. All right. I think this one should go rather quickly. So the first one, who tell me what how much they got?
I can.
Yeah, go ahead, please.
29 plus 9i.
Exactly. So this is 20 plus 9 is 29. And then 17i plus negative 8i is plus 9i. That is absolutely correct. The second one now, who tells me what they got?
Negative 4 plus 6i.
Negative 4 plus 6i, thank you. Negative 3 minus 1 is negative 4, right? You see, negative 3 minus 1 is negative 4. Because this one becomes negative 1 plus 2i when you put the negative inside. And 4i plus 2i is 6i, okay? This is the addition or the subtraction. I don't want to overdo it. I don't want to overplay it, right? It's just like, you know, you do it as usual. These are algebra expressions. You just do them. Now comes the multiplication now. So we do, for instance, 2 plus 5i, parentheses, you know, 6 plus 7i, for instance. Okay. You see, at first here, we just want to FOIL, right? We're just going to distribute. We just don't FOIL. Okay, I know all of you know how to distribute that. Go ahead. So I literally, like, you know, a couple of seconds to distribute it and see what you got. All right, at least for the distribution part right here. Okay, tell me what you have. What's this?
I'm 12.
12. Okay. What is this one now? 2 times 7i. How much do you think it's going to be?
14i.
14i. What is this one now? 5i times 6.
30i.
30i. Now comes the last one now. 5i times 7i. What do you think is going to be? Plus what?
5i to the second.
I to the second. Everybody here in this room agree with that?
Yeah.
35i to the second. Now here now the definition of I comes into play now. See, we don't let I square as is because we remember this definition. How much is I square?
-1.
I square is -1. You see right here in green, I square is -1. Now we have to consider the definition of I. I square being -1. Because I square is -1, this whole term becomes what?
Negative
Negative
35.
35.
Thank you very much. So you never leave your answer with I squared, never. I squared is -1. You have to simplify that, right? And when you put -35, there is no more I, right? The I is gone because I squared is -35. Now we can group 12 with what number? Now we can group the 12 with a -35, right? Okay. Which is -23. And these two together, how much is going to be? 14i plus 30i.
44.
44i. Do you see? This is how so basically what I squared does, I squared transform a positive into a negative into a positive. When you say 7i squared, it becomes what? -7. When you say negative 9i squared, it becomes what? Positive 9, right? When you say negative I squared, this one is a little bit more tricky. It becomes what number?
Would it be a negative? Because that's
Negative I squared become, it's going to change the sign, right? I know it's going to go, so it's going to go plus, right? It's going to become positive, but positive what number?
Positive 1.
1.
Positive 1, because the one we don't put is the invisible one right here, right? Okay. So I squared, bottom line is I squared will change your sign. If it was a plus, it will make it a minus. If it was a minus, it's going to make it a plus. That is the definition of I. So now you're going to try to do these examples right here. All right. All right, so I'm going to let you some good 5 minutes to everybody try to do these four products, everybody. I'm going to let you some good 5 minutes, okay?
Wait, so if it's a negative number, I squared, it becomes positive?
Mm-hmm.
Okay.
Exactly. That's exactly true.
Does the last one equal a whole number? The 7 is 4i, 7 minus 4i.
Say again, 7 plus 4i?
And the 7 minus 4i, is that does that equal a whole number when it comes down to it?
Yes. Yep.
Okay, good. Good.
Yeah. Yeah, I think it's been 5 minutes. So we're gonna do can somebody tell me what they did for the first one? 2 minus 4i, parentheses 1 plus 8i. Give me the steps.
I could do it.
Please go ahead, please.
So I just FOIL the 2.
Uh-huh.
1 is 2.
2 times
and
1 is 2. Uh-huh.
2 times 8i is plus 16i.
That is correct, right? And then
Then you do negative 4i times 1, and that's minus 4i.
uh-huh.
And
Then
negative 4i times positive 8i, you'll get negative 32i squared.
yep.
And
Which
becomes
becomes what?
plus 32.
Yep. That becomes plus 32. Everybody see that? It's a regular FOIL, right? Regular FOIL. The only time you're going to use the definition of I when you get to the I square. Now on the test, don't leave your answer with an I square. If you leave your answer with an I square, you don't get the credit. Okay. Okay. Now what you do? Okay. Which numbers did you group?
So I just add 2 to 32, and I got 34. And 16i minus 4i is negative 12i.
It's positive 12i.
Oop, that's what I meant.
Yeah, positive 12i. Thank you very much. That was good. Okay, so who's going to tell us the next one, please?
I can do it.
Okay, go ahead, somebody.
You go ahead.
I'll do. Thank you.
Uh-huh.
Okay, first you're going to FOIL negative 3 times 5, giving you negative 15.
Uh-huh.
And then negative 3 times negative 2i, which is going to give you positive 6i.
That is right.
And then negative 6i times 5, which is going to give you negative 30i.
That is right.
And then finally, negative 6i times negative 2i, which is going to give you negative 12i squared, which would turn into positive 12i.
Okay, let's do it again. You see, when you say negative 6i times negative 2i, you already have 2 negatives.
Oh,
this
wait.
will give you.
So it would give you another, so it would turn it back into a negative.
Yes, it's going to be 12i squared, right? And then the 12i squared will become what?
Negative 12i.
Negative 12. Negative 12 only. When you put negative 12, when you change the sign, you don't put any more i's in it. In the past, I have seen students who do that. When they change the sign of the number, if it was plus, they make it a minus. If it's a minus, they make it a plus, and then they go ahead and put I again. No, the I is gone. I squared is a number. I squared has a value. I squared is negative 1, right? Okay, so now, thank you very much. So now we're going to group negative 15 with a negative 12, right? How much you get?
So let's see, negative 15, negative 12, negative 27.
That is right. Thank you. And then the i's, how much you get?
6i minus 30i would be negative 24i.
That is absolutely right. Thank you. Thank you. So the next one. Somebody, go ahead, please.
Okay, so when you FOIL 3 times 5, 15. 3 times I, 3i plus 3i.
Yep.
1 times 5, you got negative 5i.
And then the last one.
And sorry, negative I squared.
Yep, negative I squared. Thank you. Which going to become how much? What numerical value?
1.
Positive 1. Thanks.
Yeah.
That's absolutely right. So 15 plus 1 is?
16.
16. And then 3i minus 5i is?
Negative 2i.
Negative 2i. That's absolutely right. How comes the last one? Before we even do that, do you see how the two terms look alike? You see, everybody see how the two terms look alike, right? 7 plus 4i, 7 minus 4i, right?
Yes.
Does you remind you of something? Is the previous sections?
Difference of two squares.
Difference of two squares. Thank you very much. Difference of two squares. This is a plus bi, a minus bi. So we can go ahead and do the difference of two squares, or we can go ahead and just FOIL in case somebody doesn't remember. So this is 49, right?
What is this?
This is minus 28i. This is plus 28i. What happened to them?
They cancel out.
They cancel out. And then the last one is minus 16i squared, which end up to be positive 16.
Yes.
Okay, so it is actually 7 squared plus 4 squared, right? Which is, 49 plus 60, which is 65. Okay, so basically your shortcut, what is a shortcut is, where every time you have these two numbers like this, a plus bi, a minus bi, they have a name. They are what? We have seen the word in the previous section. They are what?
Oh, conjugate.
Thank you very much. They are exactly conjugate, right? These two numbers are conjugate. And when you multiply them, your answer will be always a squared plus b squared, right? So what we say here, and here you see there's a new word here, is a plus bi and a minus bi are conjugate. Are conjugate. Okay? A plus bi and a minus bi are conjugate. What happens when you multiply them? We always get, look, when you multiply them together, when you put a plus bi, you multiply by a minus bi. You see, you get a squared minus abi plus abi. They cancel out, right? And then minus b squared, I squared, which end up to be plus b squared, right? So basically, this is a shortcut. Every time you recognize the two numbers are conjugate, you don't need to FOIL. Go ahead and write just a squared plus b squared. You don't even involve the I. The I is gone. But you have to make sure they are conjugate first. If they are conjugate first, you just go ahead and write the answer. For instance, 3 plus 5i and times 3 minus 5i, are they conjugate?
Yes.
They are conjugate. Do I need to FOIL?
No.
I don't need to FOIL. What is my final answer? 3 squared plus 5 squared. Your final answer will be always a positive number. It's going to be 1 squared plus another square, always. Isn't it that like a very good shortcut?
Yeah.
Is
I was
there?
just what if, like, for the number 4 question with the 7 and the 4i, what if you switch the second one to, instead of 7 minus 4i, you did negative 4i plus 7? Would that change the whole thing?
No, it doesn't change anything. It's exactly the same thing. They are still conjugate, right? They are still conjugate, so it doesn't change anything. So you see here, this is 9 plus 25, which is 34. Everybody sees, if they are conjugate, but you have to make sure they are conjugate, right? Before you rush, make sure they are conjugate. If they are conjugate, this is how we're going to do it. So I'm going to give you here a bunch of conjugate numbers. So first of all, if I say 1 plus 8i, what is the conjugate of 1 plus 8i?
1 minus 8i.
1 minus 8i. So you're going to multiply them and see how much we get. Okay, so all of them four are conjugate, right? So go ahead and do the multiplication. Do not FOIL. You know, we want to apply the formula. We want to take advantage of the formula. So go ahead and FOIL them. And I mean, not FOIL. Apply the formula and see how much we get. I'm gonna leave you some minutes to do that. Okay. All right, so I think, you know, if you apply the formula, this should go actually quickly. So we apply the formula. So what is the first one? Are they conjugate, first of all? Are they conjugate, first of all?
Yeah.
They are, right? So then what is the answer then?
65.
65, right? How you get to 65? You get what? You did what? What squared?
1 squared plus 8
Plus,
squared.
thank you, which is 65. You see? The second one, are they conjugate?
Definitely.
Definitely, right? So what's going to be the answer then?
85.
85, which is 6 squared plus
7 squared.
7 squared, which is 85. Okay, the next one, are they conjugate? To say yes or no, I have to see if the two numbers, the -2 and the -2 match, and if I have a plus here and a minus here, okay? Plus 4i minus, so they are conjugate. So what's going to be the answer then? Is -2 squared plus 4 squared, which is 4 plus 16, which is 20. The last one is a little bit more tricky. The last one. What is the final answer for the last one? How much you got?
Is it 2?
You got 2, right? Did
Yeah.
somebody get 0? Somebody got 0? Or everybody got 2?
I did. No, I got 0.
You got 0? Okay, so you see, that is sometimes expected because we don't involve the I when we do the shortcut. If you do the shortcut, you don't involve the I. You just involve the numbers in front of the I. You see, which we don't see here is a 1, right?
Yeah, right.
It will be 1 squared plus 1 squared, which is 2. Okay. When you do the shortcut, we don't involve the I. So every time we multiply, all these examples show that every time we multiply 2 conjugate, we get rid of the I. So if somebody is asking you to get rid of the I, that's going to be a nice idea to multiply by the conjugate, right? Okay. If somebody is asking you, if you have a number and they ask you, okay, do something to get rid of the I, that is a good idea. So this will bring us straight to the division. Of complex numbers. So look, if you have this, if you have, you do my open math and they ask you, they give you 3 plus 5i, they ask you what is A and what is B, right? Can you tell, obviously here the A is 3, the B is 5, right? Okay, if now I do this, I do 1 plus 2i divided by 3. They ask you who is A and who is B. Can we answer? Who is A here?
Is it the whole numerator, 1 plus 2i?
Just look, so we have to write like A plus BI, right? So here, because my denominator is only composed of 3, I can split. I can say this is 1/3 plus 2i over 3, right?
In that case, that makes the A 1/3 and the B 2i over 3.
Exactly. The B is 2 over 3. We don't put the I, right? You see that? This brings me to the case that's gonna here. So now if you have this now, if you have 1 plus 2i divided by 3 plus 4i. Now this is completely different now. Because of the fact we have I underneath, we have I in the bottom. I'm not ready to say who is A. I'm not ready to say who is B. Not ready yet, you see? So we are not ready to say who is A. We are not ready to say who is B. We don't know yet. And don't say A is 1/3, right? I know somebody thought about 1/3, okay? Don't say B is 2 over 4. We don't know yet. What you have to do? You have to do something to remove the I from the denominator. Okay? Before we say who is A, who is B, we have to do something to remove the I from the denominator. And the idea is not very far from here. You see those examples right here?
You square it.
If you square it, you're not applying what we did here. You see those examples? What number you need to put next to the 3 plus 4i? So the I will be gone.
3 minus 4i.
Exactly. Everybody understand that? Do you recall something similar we did in the previous section?
Yeah, we just did this.
In the previous section, do you recall what was the name of that section?
Something radicals.
Rationalizing the
denominator, that's right.
Exactly. You see, when you put the conjugate, when you multiply and you divide by the conjugate of the denominator, your wish will be true, right? So multiply and divide by the conjugate of the denominator. This is what you're going to always do. Multiply and divide by the conjugate of the denominator, right? Okay, so when you do that, your next step, according to the various examples we did before, what's going to be your new denominator now? Without even foiling, without any foil, what's going to be your new denominator? What's going to be your new denominator without any foil?
25.
It's going to be 25, right? And where you got the 25 from?
3 squared
Plus
4 squared.
Thank you. You see, my new denominator is free of I. Now the numerator I have to foil the numerator. I have to say 1 times 3 is 3. 1 times negative 4i is negative 4i. 2i times 3 is 6i. And the last one, look, the last one, since we have done this over and over and over, the last number, after simplifying, will end up to be positive 8 or negative 8. Do the math in your head. What do you think? After simplification, the last one, will it be positive 8 or negative 8? Tell me.
Positive.
Positive 8, thank you. Because it's 2i times negative 4i, which is negative 8i squared, which can end up to be positive 8, right? Plus 8. So my final answer is 11 plus 2i over 25. Now, how much is in my A now? Can I answer now how much is A? The A is 11 over?
11 over 25.
And the B is 2 over 25. So every time you have a division, what you're going to do is to multiply and divide by the conjugate of the denominator, right? Don't forget that. Multiply and divide by the conjugate of the denominator. So we have 7 plus 2i divided over 3 minus 5i. Go ahead. Do the same thing we did and then see how much you get. So you have to multiply, divide. First of all, you have to figure out what is the exact number to do. The exact number to multiply and divide by.
Excuse me.
Mm-hmm.
Can you tell us exactly what sections are going to be on the test?
Yeah, I mean, the review sheet is on Brightspace on the chapter 3.
Oh, that's right. Sorry.
Yeah, the division will not be. Is that what we are about to do? The multiplication of complex numbers will be in the test, not the division.
Okay. I forgot about the review.
Yeah. So here, what we need to multiply and divide by?
The conjugate, which is 3 plus 5i.
Thank you. 3 plus 5i, 3 plus 5i. When we do so, what's going to be my new denominator? My brand new denominator will be what? My new denominator will be
3 squared plus squared.
Plus 5 squared. Exactly. Thanks. You see, I don't need to FOIL. If I do FOIL, I will get the same answer at the end. So this is going to be 21 plus 35i plus 6i minus 10, right? Because it's plus 10i squared, which is minus 10. It's going to be 11 plus 41i over 9 plus 25, 34. So the A is 11 over 34, and the B is 41 over 34. Okay? So I will not ask you in this upcoming test about the division, but I will definitely ask you about the multiplication. Now make sure you know every single problem in the test. I think that test, if somebody reviews very well, I think they will have a good, you know, a good grade, okay? Because the material might be less annoying than the factoring stuff, right? So, but the radicals, you have to know how to simplify radicals, right? You have to know, definitely you have to know how to simplify radicals, okay? So, we will have one word problem about sharing a job. That was in the quiz number 2. You see, I know, I think by now, if you don't write the equation, you don't get the point. You have to write the equation, 1 over this plus 1 over this equal 1 over x. You have to write that equation, okay? All right, so this does close just chapter 3. Chapter 4 is about how to solve quadratic equations. So the only method we saw so far was solving by factoring. So now we're going to see some, in this chapter 4, we're going to see some other method. Quadratic. So how to solve, you know, how to solve equations, quadratic equations by different methods, right? The only method we saw, for instance, you have x squared plus 7x plus 3 plus 12 equals 0. The only method we knew is to factor, to do this is x plus 3, x plus 4, and then equals 0, and then you proceed, right? Now we're going to see some other methods. The very, very first one, at least we're going to open up the, you know, is solving by the square root property. If you have this, if you have x squared, well, if you have x squared equal to c, right? When you have x squared equal to c, what would be one way to remove the square is to put on both sides what?
Square root.
Square root. Square root does cancel a square, right? In a subtle way, you know, in a little subtle way, but they have tendencies to cancel each other. So basically, when you put square root right here, it's going to remove the square. But look right here. When you say square root, so let's see 3 square, and then you take square root. How much is that? 3 square is 9, right? How much is square root of 9?
3.
Is 3. In this case, they cancel exactly each other, right? But look at this now, this second case in green. When you do square root and negative 3 square, if you think they're going to cancel out, if they really did cancel out, what should be the answer? If they have canceled each other, the answer should be then
3.
No, we're going to see the answer is 3. But if I said, if you suppose that the square root and the square cancel exactly each other, the answer should be negative 3, right? If they just cancel each other. But in this case, what happened? What is negative 3 squared? If you go from inside to outside, negative 3 squared is 9, right? What is the square root of 9?
3.
Is 3. You see, it means, Riley, the square root, when the square is outside and the square is inside, they don't exactly really cancel each other unless the number is positive. When the number is negative, it's going to give you the opposite. You see, 3 is the opposite of negative 3. So we have the actual formula is square root of x squared is either positive x or either negative x. It has 2 different outcomes, okay? But we don't want to dig deep into that in O83 just to avoid confusing people. But that is a true formula for when the square is outside. If the x is negative, it's going to give you the opposite, okay? So that is the reason why when x squared is equal to c, then x is equal to square root of c, or x equal to the opposite, negative square root of c. We have 2 different answers, 2 possible solutions, right? Which we can summarize. Usually in the book, you can see, we write x equal plus or minus square root of c, right? Just to summarize that x is positive square root of c or negative square root of c, right? So, for instance, if I say solve x squared is equal to 16, what I do? I have the x squared by itself. What I do? I'm going to apply square root on both sides. Which I do, square root. And then, very, very important, do not forget plus or minus. Do not forget plus or minus, because we have 2 solutions, right? Always 2 solutions. So what I put plus or minus. Everybody see that? Applying the square root, I think everybody will remember that. Just don't forget the plus or minus. Apply the square root, but do not forget the plus or minus, right? Because we always have 2 solutions, not 1, but 2. All right? So that is how we solve. Now, do we know exactly how much is square root of 16? It's 4, right? Yeah. So we say x, you see, x equal to plus or minus 4. See, which is an abbreviation of plus 4 or negative 4, okay? So when you have this, and then we're going to close it out today. If you have x squared, solve x squared minus 3 is equal to 9. I know I will have to apply square root on both sides, right? I know that. But am I ready to do that yet?
No, you have to move the 3 to the other side.
Exactly, thank you. So the very, very first step is to isolate the square term. Always get the square term by itself. That's going to be always what you have to do. Before we square both sides, get the square term by itself. So we add 3, we add 3. So we get x squared is equal to 12. Now apply square root from both sides. Second, now apply square root. Okay. So which we do that, we do square root, but we do what we don't forget again to put
The plus or minus.
the plus or minus. If you forget the plus or minus, you just gave one solution and you forgot another one, right? We have two solutions. So we get x equal plus or minus square root of 12.
So, but do you don't simplify it more?
You don't need to, because here in this topic, we don't need to simplify. You could, you can simplify just to practice the simplification, but you can leave it like that. Okay. All right, so we're gonna leave it now. I know everybody gonna focus on the test, so please take the review sheet until you know that you can do every single problem by yourself. I repeat again, do not miss the quiz. Please don't miss the quiz, right? Don't miss the quiz, and then also when we get into the Zoom, the Teams, it's on Teams. When you get into the Teams, please try not to get to check out from the session before you submit your test. Okay. So good luck to everybody. If you need help, you can write me, email me, or come to my office hours. So see you Tuesday for the test.
Okay, thank you.
Thank you very much, everybody. Thank you.
Thank you.